Alright, so accurately sketch a graph of the function f of x equals x squared plus 1 on the interval 0 to 2. Draw a right Riemann sum with 4 equal subintervals for the function and the given interval, and calculate the sum and explain how this approximation compares to the actual area. So we're going to do some integrating in FTC right there. So I'm going to sketch a graph to represent this. We're going in x squared graph that's been shifted up by 1. So we know that first point right there is going to be 0, comma 1. And we're going to go all the way up to 2 right there. So split it in half. There would be 2 subintervals right there, and we need 4 subintervals. So we're going to look at those subintervals right there. So let's make a data table here for x and f of x to help us with our calculations. So we're going to need 0, 0.5, 1, 1.5, and 2 right there. So let's find these values for f of x. Well, at 0, plug in 0, you get a 1. At 0.5, we're doing 0.5 squared, which is 0.5 times 0.5. So think of it as 1/2 times 1/2 is 1/4. Plus 1 is 5/4. Plug in 1. 1 squared is 1 plus 1 is 2. What about 1.5? Well, 1.5 is 3/2. We're doing 3/2 squared, so we're getting 9/4 plus 1. So 9/4 plus 4/4 is 13/4 right there. And then finally 2. 2 squared is 4 plus 1 is 5. So we have our points, and now we can sketch them in. I'm going to sketch the easy ones first. 0, 1, 1, 2. So let's go 2 right there. There's that second point. 2, 5. So 1, 2, 3, 4, 5. So we're going to be all the way up here at 2, 5. Now I can go and kind of approximate. 5/4 is 1.25. So that's going to be, somewhere around there. And then at 1.5, 13/4, well, 12 over 4 is 3. So this is like 3 and a quarter, so 3.25. So 1, 2, 3.25 puts us about there. So you can picture there's our parabola going up like that, but we're doing a right Riemann sum, which means we're putting the right endpoint on the graph for these intervals. So first one is going to go over like that, and then the next one is going to use that next right endpoint to give us that rectangle, and then the next one giving us that rectangle right there, and then the last one giving us that fancy rectangle right there. So we know that these subintervals, these rectangles, all have the same width. They're all 0.5. So in our calculation, we're going to get a 0.5. I like fractions. We're going to get a 1/2 times the sum of all of those heights. So we are going to take the height of the purple one, which has the y value of 0.5. So 5/4, plus the height of the green one, which is the y value at 1, which is 2, plus the height of the black one, which is the y value of 1.5, which is 13/4. And then finally, plus the height of the pink one, which is the y value of 2, which is 5. So let's add all that up. Sometimes I like decimals, sometimes I like fractions. Let's think we're doing 1/2 still, but we're going to end up with what? 2 plus 5 is 7. 7, and let's think 5/4 is really 1.25. 13/4 we said is really 3.25. So we know we're going to get a 2 plus 5 is 7, plus 1 is 8, plus 3 is 11, plus 0.5 is 11.5. 11.5 is the same as 22/2. And so we get that fraction right there, which is 22/4, which we can simplify to 11 halves, which we can say, if we want to, as 6.5. That is the area right there of that Riemann sum. It's a right Riemann sum because the right endpoints are being used. The right endpoints of the rectangle are telling us the height of the rectangle. We calculated the sum. It's 6.5. Explain how this approximation compares to the actual area. Well, picture the actual graph going in. So let's sketch that actual graph in with, I don't know, how about this fuchsia color? The actual graph is going like that. So if you think about it, each area that we calculated is actually an over approximation. So we calculated an over sum right here. So let's use the fundamental theorem of calculus to figure out what this actual value is. So we're looking at the integral. Why is my symbol so bad? The integral from 0 to 2 of the function, which was x squared plus 1 with respect to dx. So integrate x squared plus 1, we get x cubed over 3 plus x evaluated from 0 to 2, which means we get 2 cubed over 3 plus 2. 2 cubed is 8, so we get 8 thirds plus 2, which is 8 thirds plus 6 thirds, which is 14 thirds, which is what? Let's see, 12 thirds would be 4, so it's 4 and 2/3. The actual area here is 4 and 2/3, so 4.6 repeating. So, if you look at all this area above the graph right there, that was all over approximation, which we see in that our area we approximated was 6.5, but the actual area there is 4.6 repeating.